You're sitting in a Cisco technical interview, and the hiring manager asks you to explain firepower threat defense. You have 30 seconds to prove you can secure a network. Most candidates respond with a textbook definition they memorized 5 minutes ago. While factually correct, this often leaves the interviewer wondering if you've ever actually managed a live production environment. To demonstrate that experience, you can structure every answer using a specific framework: definition, example, and use case. First, the definition. This is a concise technical statement that identifies exactly what the technology is. Second is the example. This is where you describe a practical scenario of the technology actively managing traffic. Finally, the use case. You close the loop by explaining the business value, the specific reason an enterprise needs to deploy this feature. Using these 3 steps together shows that you understand both the technical mechanics and the operational context. Let's apply this framework to the core concepts you'll face in the hot seat. Most technical screens begin with the baseline, the legacy ASA, or adaptive security appliance. By definition, an ASA is a stateful firewall that filters traffic based on IP addresses, ports, and protocols. The practical limitation is visibility. If you allow traffic on TCP port 443, the ASA permits it, even if that connection contains malware or a malicious payload hiding inside the encrypted stream. Firepower Threat Defense, or FTD, is the next-generation firewall designed to solve this. It looks past the port to inspect the actual application behavior. The FTD architecture integrates 3 components into one system: the ASA engine for layer 3 and 4 filtering, the Snort engine for intrusion prevention, and an underlying Linux OS. This design creates a heavier processing load, but the use case justifies it. It provides the deep, layered security that modern enterprise networks require. Transitioning from ASA to FTD shifts your security posture from simple port blocking to deep application-aware protection. Beyond the firewall itself, you'll be asked how to manage multiple devices across a large organization. That is the role of the FMC, or Firepower Management Center. It is the centralized management system for configuration and monitoring. For an example, an admin writes a security policy in the FMC and clicks Deploy to push those rules to dozens of FTD devices simultaneously. Be ready for the follow-up question. What happens to the network traffic if the FMC server goes offline? The FTD devices continue processing traffic without interruption, using the last policy you successfully deployed. This separation of the management plane from the data plane provides central control without introducing a single point of failure for the network. To be considered a true next-gen firewall, FTD relies on specific inspection tools, starting with AVC, or Application Visibility and Control. AVC identifies and controls specific applications, regardless of the port or protocol they attempt to use. For example, AVC can block the YouTube application, even when it tries to run over standard HTTPS port 443. Once the application is identified, the traffic is inspected by the Intrusion Prevention System, or IPS. The Snort engine analyzes the traffic allowed by your policy, searching for malicious behavior through signature and behavior analysis. A common example is detecting a SQL injection attack embedded inside a legitimate-looking web request and dropping the connection. The third layer is URL filtering, which manages website access based on category and trust reputation. URL reputation scores protect your users by immediately blocking known malicious sites before a session is fully established. This sequential flowchart shows how these tools coordinate. Traffic enters the access control policy, moves through IPS inspection, proceeds to NAT, and is forwarded. During NAT, private IP addresses become public. You choose static, dynamic pools, or many-to-one PAT based on conservation needs. Coordinating AVC, IPS, and URL filtering within this single flow is what defines FTD's enterprise-grade capabilities. The rule engines that govern these features create a clear distinction between basic and advanced security, the difference between an ACL and an ACP. An access control list, or ACL, provides basic traffic filtering limited to IP and port parameters. An access control policy, or ACP, is the advanced engine required to enable AVC and IPS inspection. When you're deciding which to use, the criteria is simple. If the requirement calls for application or IPS inspection, you deploy an ACP. For simple layer 4 filtering, an ACL is used. Because simple ACLs cannot inspect these modern threats, mastering the ACP is essential for providing actual next-gen security. To keep the architecture clear, FTD is ASA plus IPS, FMC is the central brain, AVC provides application control. Now, test your own knowledge. Try to explain the FTD traffic flow out loud right now. Next, practice explaining exactly why an ACP is the better choice than an ACL for a secure environment. Finally, describe the sequence of how IPS and AVC work together to inspect a single packet. Remember to apply the framework to each of these answers. Provide the technical definition, the practical example, and the business use case. Demonstrating your understanding of these architectural trade-offs, rather than reciting definitions, is how you prove your expertise and land the job.